relationship between roots and coefficients. So we're going to start off by just looking at a generalized quadratic equation. So ax squared plus bx plus c equals 0. And we're also going to look at, if we knew the roots of the quadratic equation were alpha and beta, the quadratic equation could also be expressed as x minus alpha multiplied by x minus beta equals 0 if the roots were alpha and beta. Now, we're just going to take the first quadratic equation, our generalized one, and divide everything by a. And we're going to get this new monic quadratic equation, because this equation on the right is also monic. So we'll expand everything out. So we get x squared minus beta x minus alpha x plus alpha beta equals 0. We're just going to group these x terms together. So we're going to have minus alpha minus beta all times x plus alpha beta equals 0. So these are two forms of a quadratic equation we can have, and since they're both equal to 0, we can actually just make them equal to each other. So we get x squared plus b on a x plus c on a equaling x squared plus minus alpha minus beta x plus alpha beta. Now, if these quadratic equations are going to be equal, their coefficients are going to have to be equal. And we can see that 1 equals 1. So this coefficient must equal this coefficient, and this coefficient must equal this coefficient. And we actually get some special results. So we get b on a equals minus alpha minus beta, which we can then factorize out the negative. So we get alpha plus beta, and take it to the other side, and we get alpha beta equals minus b over a. And we also get alpha beta equals c over a, equating the constant terms. And these two results actually give us a relationship between the coefficients of the quadratic equation that we had and the roots that we had. So you can see the sum of the roots equals minus b over a, and the product of the roots equals c over a. And this is just for a quadratic equation, but we actually have some other results for cubic equations and quartic equations, and they're derived in a similar way, and I'm not going to go through them, but I'll show you what they are. So the ones for a cubic equation, so obviously for a cubic equation we're going to be looking at 3 roots. So for a cubic equation of the form ax cubed plus bx squared plus cx plus d equals 0, where the roots are alpha, beta, and gamma, we have the results that alpha plus beta plus gamma equals minus b over a. We have the result that alpha beta plus alpha gamma plus beta gamma equals c over a. Then we have the result that alpha beta gamma equals minus d over a. And all of these results are for our cubic equation. What about a quartic equation, where we have it in the form ax to the 4 plus bx cubed plus cx squared plus dx plus e equals 0, where this time the roots are alpha, beta, gamma, and theta. So sometimes you might see delta, but I'm using theta. So we have the results that alpha plus beta plus gamma plus theta also equals minus b over a. Alpha beta plus alpha gamma plus alpha theta plus beta gamma plus beta theta plus gamma theta equals c over a. Alpha beta gamma plus alpha beta theta plus alpha gamma theta plus beta gamma theta equals minus d over a. And alpha beta gamma theta equals e over a are all our results for our quartic equation. Now, some things to note is that all of them are divided by a, even in the quadratic as well. The signs alternate, so minus, plus, minus, minus, plus, minus, plus, and the coefficients go up by 1, b, c, d, b, c, d, e. Also, if we think about it in words, it'll be hard for us to forget. So this is just the summing of the roots 1 at a time, summing of the roots 2 at a time, and this is the product of the roots, summing of the roots 1 at a time, summing of the roots 2 at a time, summing of the roots 3 at a time, and the product of all the roots. So if we were to have an equation to the power of 5, you could guess that it involves summing the roots 1 at a time, summing the roots 2 at a time, summing the roots 3 at a time, summing the roots 4 at a time, and then the product of the roots. But we don't have to know how to do an equation to the power of 5. Let's do some examples. So let's start with a quadratic equation where we have 2x squared plus x minus 6 equals 0. And the first thing we're after is just the sum of the roots, alpha plus beta. Now we know alpha plus beta equals minus b over a, and that's just going to be minus 1 over 2, which is going to be our answer. Second part, what if we wanted to find the product of the roots, alpha beta? Well, alpha beta just equals c over a, and that's just going to be minus 6 over 2, which is going to be minus 3. What about if we wanted 1 over alpha plus 1 over beta? So this is adding the reciprocals of the roots. Here we need to just do a bit of manipulation first. So we can times our first fraction by beta over beta. So we get beta over alpha beta. Then our second fraction by alpha over alpha. So we get alpha over alpha beta. Now they have the same denominator. So we can just add the numerators together and get alpha plus beta over alpha beta. And we know that alpha plus beta equals minus a half, and we know alpha beta equals minus 3. So we just get minus a half all over minus 3, which is going to give us positive a sixth. What about alpha squared plus beta squared? Well, here we're just going to need to do a bit of manipulation because we don't have an expression for alpha squared plus beta squared. We only have an expression for alpha plus beta. Alpha squared plus beta squared is almost the same thing as alpha plus beta squared. But if you expand this out, you'll get alpha squared plus 2 alpha beta plus beta squared. So it's not quite the same thing because we have this extra 2 alpha beta term. So if on the original we minus 2 alpha beta, we'll actually get the same thing. So now they are equal to each other. And that's very helpful because we know what alpha plus beta is. That's minus a half. And we know what alpha beta is. That's minus 3. So we just end up with minus a half squared, which is a quarter, minus 2 times minus 3 is 6, and that's going to give us 25/4. Let's have a look at an example of a cubic equation. So we have x cubed minus 6x squared plus 5x plus 12 equals 0. And the roots are alpha, beta, and gamma. So what could be helpful first, before we look at any questions, are just finding the expressions. So let's find an expression for alpha plus beta plus gamma. We know it's equal to minus b over a, which is just going to be minus 6 over 1, which is just going to be 6. Let's get an expression for summing the roots 2 at a time. So alpha beta plus alpha gamma plus beta gamma. And that's going to be c over a, which is going to be just 5 over 1, which is just 5. Summing now the product of the roots, we're going alpha, beta, gamma. That's just minus d over a. So we're just going to get minus 12 over 1, which is just minus 12. Now we'll go ahead and look at some questions. So first question, let's look at 1 on alpha plus 1 on beta plus 1 on gamma. So this is going to require a bit of manipulation. So if we just make it into a single denominator of alpha, beta, gamma, it's our common factor. Alpha goes into alpha, beta, gamma times, and beta gamma times 1 is beta gamma. Beta goes into alpha, beta, gamma times, and alpha gamma times 1 is alpha gamma. And gamma goes into alpha beta times, and alpha beta times 1 is alpha beta. And hopefully you should be able to see that that's just the sum of the roots 2 at a time, which is 5, over the product of the roots, which is minus 12. And that's going to be our final answer. What about alpha squared plus beta squared plus gamma squared? Well, just like the quadratic equation, this is actually just going to be alpha plus beta plus gamma all squared minus 2 times alpha beta plus alpha gamma plus beta gamma. So it's the sum of the roots squared minus 2 times the sum of the roots 2 at a time. And we know that the sum of the roots is 6, so we're going to have 6 squared minus 2 times the sum of the roots 2 at a time, which is 5. So we're just going to get 36 minus 10, which is 26. All right, now let's look at one more example with a quartic equation. So let's have p of x equaling minus ax to the 4 plus bx cubed minus cx squared plus dx minus e. We're going to say that p of x has 2 double roots. So if p of x has 2 double roots, the first thing we can say is that the roots must be alpha and beta. So because 2 of the roots double up. So the first question is just to find the sum of the roots. So the sum of the roots is just going to be alpha plus beta. And we know that equals minus b over a. So we're going to get minus b over a, which is negative a. So it's going to give us 2 alpha plus 2 beta equals b over a. Factorize out the 2. So we're going to get alpha plus beta equals b over a. So alpha plus beta equals b over 2a. And that's the best we can do at this point because we don't have any more information. Part 2 is to just find the product of the roots. So we're going to get alpha times beta times beta. And we know that's going to equal e over a. So we're going to get e is minus e, a is minus a. So we're just going to get alpha squared, beta squared equals e over a. We could leave it like that. Or we could write it as alpha beta all squared equals e over a. Now, next part is to show that E equals 4AC minus B squared, all squared, over 64A cubed. Now, this obviously relates A, B, C, and E all together. And we have expressions for AB and sum of the roots and EA and the product of the roots. And a good place to start might be just to look at the sum of the roots 2 at a time, because it's something we haven't looked at. So summing the roots 2 at a time, we're going to get alpha beta plus alpha gamma plus alpha theta plus beta gamma plus beta theta plus gamma theta, all equaling C over A. Now, what we can do is wherever we see alpha can be alpha and beta can be beta, but another alpha could be gamma and the other beta could be theta. And that's going to help us simplify the expression. So alpha beta can stay as alpha beta. Now wherever we're seeing gamma, we're putting alpha, so it's just going to be alpha squared. Theta is beta, so we're going alpha beta. Gamma is alpha, so it's just another alpha beta. Theta is beta, so it's just going to be beta squared. And gamma is alpha and theta is beta, so that's another alpha beta. Now C is actually negative C in our equation, and A is negative A. So collecting like terms here, there's 4 alpha betas, so we can say 4 alpha beta plus alpha squared plus beta squared equals C over A. Now, the alpha squared plus beta squared, we can write as alpha plus beta all squared minus 2 alpha beta. And we've got the plus 4 alpha beta here still. So we can go ahead and just do 2 minus 2 alpha beta plus 4 alpha beta. So we're going to get alpha plus beta all squared plus 2 alpha beta equaling C over A. We know alpha plus beta equals B over 2A. So let's go ahead and sub that in. So we're going to get B over 2A all squared plus 2 alpha beta equals C over A. So let's make 2 alpha beta the subject. And we'll say C over A minus B squared over 4A squared. And let's go ahead and divide everything by 2. So we'll say alpha beta is going to be C over 2A minus B squared over 8A squared. Let's bring that right hand side together. So we're saying alpha beta. So we can times our first fraction by (4a) over 4a to make it have the same denominator. So then we're going to get 4ac minus b squared over 8a squared. Now let's go ahead and square both sides. So we're going to get alpha beta all squared. The reason we're going to do that is because we have an expression for alpha beta all squared. So we can say that equals 4ac minus b squared all squared over, well, 8 squared is 64 and a squared is a to the 4. We can go ahead and sub our expression for e over a into alpha beta all squared. So we're going to get e over a equaling 4ac minus b squared all squared over 64 a to the 4 times both sides by a. And what's going to happen is that's going to cancel with that and become cubed. And we've successfully showed that e equals 4ac minus b squared all squared over 64a cubed.